Okay, well let's take a look at a few customer success stories, people that have applied FDT. And these have been set up not to be all the big mega success stories like you might typically expect, but we've taken a pretty full range of stories of different size companies and organizations and how they applied the technology differently so that you get a little sense for scope, scale, where you might start. One of the questions I'm often asked is, where do I get started? This sounds interesting, what should I do next? And you'll see some of these companies really just dip their toe in the water to do some asset management, some diagnostic kind of things. You know, you can start it as a benchtop project with a few extra devices or I/O cards or whatever your environment is and just set up a sample system on a bench to start playing with it. I think you saw in a couple of the demos where they actually installed DTMs, you saw it's fairly straightforward. And I think once you get used to where those mouse clicks are on your own, you'll be equally proficient in setting up a basic network. So we encourage you to get started, but I think here you'll see companies that took it to all different scale and scope type activities. Oops. So first company to talk about is Arkema. This is a company that was founded in 2004 that came out of Total's chemical group. So they reorganized it into this new company. And they produce a wide variety of things, vinyl products, industrial chemicals, all sorts of things. They're in 40 countries, 17,000 plus people, and they have 80 sites just in Europe, in North America and Asia, sorry. We want to talk about, though, one specific plant, just give you some highlights from what they did in southwestern France. This particular plant manufactures hydrazine hydrate. Anybody know this stuff? Anybody familiar with it? This is one of those chemicals that most of us have never heard of, but it's used in almost everything we touch. So if you use any kind of insulated foam type products for building, you know, the expanded foam, this is the stuff that makes it foam up. It's used in to produce all of our automobiles. The airbag systems in the cars use that little cylinder of gas, and it's often this chemical that's part of the process to produce that little cylinder of gas. It's used in vinyl siding, it's used all over the place. So it has very wide use, but in the consumer market you never hear about it because it's such a base level chemical into so many other processes. So unless you're a chemical engineer or something like that, it wouldn't be unusual that you hadn't heard of this. But it's huge in scale. They're producing 47 tons of this stuff a day. It's also a very volatile product. It has to be stored or mixed with liquids in order to make it a stable product. So you don't see it in a dry form, it's in a liquid form. One of the other interesting uses for this is it's been used in many satellites and rocket programs because it can be used as a propellant in a rocket system without burning it. So it's a unique characteristic that way also. Used in fuel cell systems, if you like following alternative energy kind of schemes, it's used in certain fuel cell chemistries, things like that. So here was their challenge. They had a Foxborough IA system in their facility controlling this hydrazine plant. And they wanted to go from essentially what was an analog instrumentation system to a digital system to start taking advantage of diagnostics and all the other features that it offers. So they went with HART in their case. For those that aren't familiar with HART, just real briefly, HART really is the old 4 to 20 milliamp instruments. So it's a current loop instrument, and the primary process value still comes via that current loop. It's a measured current loop in a 4 to 20 milliamp range. But what makes it effective as HART is that they put a digital signal on top of that 4 to 20 milliamp signal. So on the same two wires, on the same pair of wires, you can superimpose this digital signal. So now you can communicate with that device digitally and start to get to diagnostics, advanced configuration, and other things. So that's the HART network. Probably one of the most widely installed communications protocols. Most people would be quick, if you're familiar with it, they would be quick to say, hey, let's be clear though, HART technically isn't a network. because it can only go from a bus to the individual devices. You can't just put multiple devices on the heart bus, as it were. So I think their wireless situation has started to change the look of that a little bit. It's starting to look a little bit more like a network, but it's the most widely installed in terms of devices out there in the process industry. Okay, and they wanted to avoid the very issue that we talked about that FDT addresses, and that's you don't want to have all these different configuration and maintenance tools for all the different devices that were installed in their facility. And then in their case, like many chemical plants, petrochemical plants, and other processes, there's areas of the facility that are explosion areas or hazardous areas that you just don't want to go into if you can avoid doing it. It's possible, you could take special tools, in some cases special clothing, suits, and so on to do it, but it's a real pain to have to do it. So one of their objectives was to avoid having to go into those hazardous areas whenever possible. And then they had some control loops that they wanted to optimize, so they wanted to take advantage of the digital functions in the devices to be able to help them do that. So that was their objectives of this facility. Here's the types of instruments that they put into there. This is a shortened list of those, but it's almost like that first user story we showed you in Singapore, where it's just a wide variety of instruments. So here's a good example where the customer has a combination of both selecting best-in-class devices and having to deal with a whole legacy of instruments that are in their facility and being able to integrate it into a single system. So pretty diverse. Here's what the architecture then looks like, and just, it's a little bit small here, but over here you've got workstations with various functions. These are all on Ethernet backbones, just going into Ethernet switches up here. Then you come down onto the heart level of the application, and these are all heart I/O points down here. So a substantial size installation sitting on as a system IA series configuration. So here's what they did. This is their solution to this. They took an installation of FDT and used Packware as the base frame. You've heard about Packware several times today. So that's one that they chose. And then they took the DTMs from companies like this and implemented it into that Packware frame. All the heart communication cards handle the conversion between the Foxborough IA series and the heart instrumentation. This is a screenshot of one of their implementations. And what you've got here, it's hard to see on this chart, but you can see there's bars here. And you might notice there's some red bars over here and some red bars over here. This is a histogram of a valve positioner in that application. So you saw with the rotor demonstration that they were talking about the amount of torque it takes to open and close a valve and how that changes over time depending on the health of that valve. And you can trend that information, look at it, and you can actually start to predict with that data when it's going to be time to maintain that valve. You don't have to guess, you don't have to put it on a calendar and hope you were right. You just look at this data. And it'll actually show you very clearly that the valve is trending towards a maintenance need. And that's what these red bars are, is where it's starting to require too much force for the effort involved in positioning that valve. And the more that it starts to show up in the red zones, you can see the far majority is within an acceptable range. So this valve is probably in pretty good shape, reported by the positioner at this point. Okay. They had 150 of these things in their installation. So you can imagine if you did this the old way with valves, where you would just put it on a calendar or in some kind of maintenance cycle on your computerized maintenance management system, what have you, the results would be substantially different than what you get through intelligent information like you see here. You can do things like deviation analysis, all sorts of things are possible, and as you saw with Rotork, you can set alarm limits. There's all sorts of things you can do to help you with this issue, and that was one of the key things that they wanted to get after with their 150 valves. Here's a little better look, I guess, at one of those. You see the friction history, and here you can see there were a few events, or a few percentage of the events, where it was more than acceptable friction for operation of that valve. as that would trend up over time, you would start to say, clearly we've got a maintenance issue starting to develop. And you could probably schedule it during some planned downtime, or at least schedule the downtime instead of waiting for a complete valve failure to occur. They had a couple really key valves in their application that they determined were critical valves, and you see them here in these pictures. They had a general steam valve, the steam supply for the process, and they had a column level control valve that were basically cannot fail type applications, otherwise a large part of their process goes down. So they used the DTMs to allow continuous monitoring of the friction in those valves so that they were sure that the application was working. It's a beautiful example. As we said earlier in the day, one of the hot topics of people applying FDT technology is the advanced diagnostics. And here you've got it working in a very critical chemical process, doing exactly that, monitoring critical valves and all the other valves. Any questions on that application, comments? Okay. Here's a few more screenshots, just their thanks to all the companies that were involved. You can see some more DTMs, and by now you're getting pretty used to the look. You can spot an FDT application from a PowerPoint away. So there's the DTMs, there's the plant structure, some more DTMs for other devices, and so on. So they met their goals, and they're doing better on their diagnostics, their service personnel, and so on. So they've done a nice job of applying FDT. That's what they say here. So, consistent with some of the things we were talking about earlier in the day, they've achieved in their particular application. Comment from their M&I manager. I won't read it for you. You can just take a look at it. I think it's a nice summary from his part. You know, just a nice user story. I'm sure it was a lot of effort on their part, but you can see the results came through nicely for them. Okay. Now, interestingly, I'll transition to another user of FDT technology. This is a company in South Africa. So this is Sasol Corporation in South Africa. And surprisingly enough, Arkema supplies to Sasol. So here's some of that chemical coming in its container, and they actually mix it with a fuel-based product for leak detection while it's being transported. And so you've got a leak detector sitting here so it can sniff if there's any leaks from the container, so it can be dealt with before it becomes a local site disaster from a continuously leaking container. So anyhow, that transitions over to this company called Sasol. Sasol is a huge, essentially petrochemical refining facility in South Africa. This is one view of it here. And I'm sure this is typical of your plants where you have giraffes in the front of it and some zebras, and I think those are wildebeests back there. That's what I get every time I look out my plant window. Maybe it's an amazing shot. It just sums up Africa in so many ways. But yeah, you can see so the cooling towers here, obviously a huge spread out cracking, processing type facility. They're using Hart and Profibus throughout the plant. So here they're using two different networks. Again, you know how well that works from the FDT structure. Their issue was this thing is just too big to send out technicians for everything that has to be done. You know, you send out a technician to check one valve or one instrument, and they're probably gone for half a day in a facility like this, just checking out that one thing. Not to mention similar issues that I said before, and that's often these are very hazardous areas, places you just prefer to keep people away from if you can. A little better shot closer up to the facility. It gives you some more idea of the scale of this thing. So what they were after is to be able to get easy access to calibration of devices with FDT. That was their goal, without having to run all around it. Same thing, they were saying they've got too many hazardous spots to be able to do this right at the instrument, just is not practical. They were looking for the ability to essentially do it from a central location and do as much of the calibration and validation as possible. So they did that using the Hart protocol directly from the control room. So now you can imagine, if you're the I&A manager of this facility, to be able to sit in a control room and do these kind of calibrations compared to having somebody, an army full of technicians running around on this campus is a far superior solution. This is another plant in South Africa, and this is a coal mine, a working pit coal mine. The picture is just a little blurry, but you can make out the tiered levels of the coal mine here, and they're working their way down in this pit. And then this is the processing facility here, and these are rail lines and other logistics coming in for that plant. Okay, so a huge coal mine in South Africa. They decided to use Pactware as their application for maintenance and calibration activity. Again, you've got a situation where running around in here isn't of a lot of value. They like the DTMs to help them with it. They do have the ability, the way was pointed out earlier, where you can do local control of instruments, so that's what they do for benchtop type work. They have it set up so that they just have a local heart modem, and they can configure devices and maintain them right on the benchtop, or they can do it from the control area. And this gives you a couple of nice views of what their issues are. This is a catwalk that frankly doesn't look like the kind of shape I'd want to be walking on to do some maintenance of instruments that are clamped up there. And then this is the view in the other direction. Look how high up you are in this structure to do instrument maintenance and those kind of things. Just not practical from a safety and from a time perspective. So they were able to allow their people to do most of this work that they previously had to send out just by implementing that Pactware, simple Pactware frame with the DTMs. They were able to get remote access to their instruments. Now, these last couple of examples, it's worth thinking about for your facilities that this is often done as an add-on on top of the control system. So it's not replacing the control environment to be able to put these applications in. It's added on top. You need to do some analysis about network bandwidth. Do you have the right number of gateways to facilitate it, and some other things. It certainly isn't the kind of thing you want to go and just slap it on and hope that your control system doesn't fail because now you're doing asset management. Wrong approach, but it is definitely done time and time and time again where a frame application is set on top of the control system to do the asset management, calibration, and other kind of work. And that's what you've seen in these last couple customer examples. You notice they didn't talk about replacing the control system. It was added to their working environment. So another company, do you get these commercials from this company in the UK? We get them in Germany fairly frequently. They advertise a green commercial where they're replanting trees and helping to make sure things aren't deforested. Do you get these commercials here? I don't know why we get them in Germany, but we sure do. Anyhow, this is a huge paper manufacturing company, and one of the products, of course, is cellulose that's used in clothing and all sorts of applications, cell phones, plastics in general, lipstick, all those kinds of things. And that's what they're making in this plant in South Africa. Here's a little bit of their network situation. So they use Pactware on a Profibus network in their example. And they use the different DTMs from a number of manufacturers, so they've got this mixed topology going on. And they also had some field bus mixed in with that network as well. But again, here's a fairly large plant that did this as an add-on project to be able to handle the asset management activities in their facility. Now let me step you down to a really, really small user of applications. Anybody ever been to Botswana here? No? I've had the opportunity to go a few times. And it was interesting, I think it was just last week, maybe the week before, where the Botswana government, this is just above South Africa to the east of South Africa, the Botswana government announced it's stopping commercial hunting. No more commercial hunting, meaning, if you want to go there and hunt any of their animals, you can't do that anymore. So, and that was a huge industry for them. It's interesting that they do that. But I say that because of this elephant picture, because this is very typical when you're driving in Botswana, that you have to stop not for one elephant, but for 50 elephants crossing the road. You just have to stop and wait for them to take their good-natured time to get across the road. And these elephants will come through and just clear all the trees as wide as they're walking. There'll be no more trees left because the bull elephants love to just uproot trees to show what they can do. So it's something to do with their pecking order in the herd of elephants. But after they've gone through, you can look down this 100-meter wide path where they've walked through and there's no more trees left. And so the residents hate it because the elephants are taking over everything, ripping down all the trees. And now they've stopped commercial hunting, so I'm not sure what they do. Maybe birth control for elephants or something. But
Is control elephants with backware?
yeah, with backware, yeah. Get a DTM for that. No details, please. Okay, so anyhow, so this is a little application of Botswana. Botswana is a small, relatively poor country. They don't have a lot of infrastructure. Their cities are really basic. And even in their major cities, these are scenes what you would see. Here they've got, though, a diesel depot, okay, and then they've got their control panel sitting here to manage this diesel depot. For those of you who would like to open up your panels and see the nicely ordered cables and all the labeled terminal blocks and everything, this will be a real disappointment to you, the rat's nest of cables, and they're just hardwired up to everything, but that's Botswana for you. So anyhow, they're controlling and monitoring the level of these pressure, or these diesel tanks in this application. So they wanted to do a remote calibration of the tanks, and they wanted to be able to find out what levels they've got, what's the consumption rates, and so on in these tanks. So here's what the application looks like. This was done by Vega, who you saw in the other room, and this is actually pictured on a web-based application. You notice this is a browser up here, but they're able to look at the history, the storage of the various tanks, their capacity, and so on, in addition to doing the calibration of those devices remotely. So there's a really small customer, you know, with very limited application that just took an FDT frame, loaded up with the necessary DTMs, and they were in business, and doing it over fairly slow landline type connections. So you don't always have to think about this as high-speed Ethernet backbone connections. You know, within reason, you can use dial-up lines, satellites, cell phone, GMRS connections. Many applications are done that way for either remote monitoring or calibration of that type of equipment. So there you go. So here's a couple of cute comments from these guys standing on their tank farm. So there you have a few basic case stories from different types of users around the world that apply FDT. I think the key message is the scalability of what you do with it. Really depends on what your needs are in your facility. You can do it from complete, fully automated, integrated control applications along with your DCS or your PLC system, down to simple asset management, bench type activity using exactly the same frame and exactly the same DTMs to get the job done. And you can scale it anywhere in between there. Hopefully today you also recognize when you saw someone where they built some of the project trees, how easy it is to then add other networks to it as your experience or requirements grow, and just keep scaling up the system as you go.